Hello everyone, my name is Haris, and in this video we're going to be going through LeetCode number 55 jump game. For this problem, we're given an integer array nums and we're positioned at the first index, so here, and each element in the array represents the maximum jump length for that position. So let's say we're at the first index and this is a 2. So we can have a maximum jump of 2. So what that means is that we can jump anywhere until the index plus 2. So the index for the first element is 0. So we can jump 0 plus 2, which is just 2. So this is the maximum jump that we can have, which is until here. But that also means we can jump everywhere before that. So we can also jump here, and we can stay at the same place, but that doesn't really do anything. So we have to return true if we can reach the last index, which is just this element, or false otherwise. So starting from the first index, we need to see if we can reach the last index by some path of jumps. So let's see if we can even reach the end with this example. So we can see that this is a maximum jump of 2, so we can first jump to index 2. Then from index 2 we can jump 1 until index 3, and then we can jump once more to index 4. And we've reached the end, so the output for this example is true. Instead of determining all the possible jump combinations, so from index 0 we can jump to index 1 or index 2, so we can have a tree that looks something like this. And these are the indices, and then from 1 we can jump to 2, we can jump to 3, and we can jump to 4. And then from index 2 we can only jump to 3. So we can keep building out the tree like this. And this would be 2, 3, and 4. And then we know that the last index is 4, so we can reach via this path. But this is going to have an insane time complexity because we never know how many possible values there are. Each one could have a value up to n minus whatever the index is. So we're getting close to a time complexity of something like big O of n to the n. We can optimize this solution, but I'd like to present a much faster solution and a more intuitive solution using the greedy algorithm. And this algorithm is going to have a time complexity in the worst case of big O of n, so linear time, and it's going to have a space complexity of big O of 1. So instead of starting at the first index, let's start at the last index. Now we know that a solution exists or a path exists if we can reach this value by jumping from one of these elements. So we can just move and traverse backwards in reverse and move the finish as we find elements that are possible to be jumped to. So I'll show you what I mean. We can start from this element since we want to reach to the last element. We check to see if the jump value plus its index is greater than or equal to the goal value. So in this case it's 3. So 3 plus the jump value, which is 1, if it's greater than or equal to the finish value. And the finish value right now is at 4. So if this is true, then we can reach this value. Then we need to find a value that reaches this one. And obviously this inequality is going to be true. So we can go ahead and shift the finish to 1 before. Now we check this value. We see 2 plus the jump value if it's greater than or equal to the finish, which is at index 3. This is again true, so we can try to find a path that we can reach for this index. So we take a look at 3, and 3 is going to be the index at 1 plus the maximum jump value, which is 3. If it's greater than or equal to this value, so it's obviously true, 4 is greater than or equal to 2. So we can shift the finish to index 1. And then we take a look at 2. We check 0 plus the maximum if it's greater than or equal to the index of the finish. And yes, it is. 2 is greater than or equal to 1. So now we see we have the finish at the 0th index of the array. And this is exactly what we need since we started at the last index and we reached the first index. So there is some path that can lead us to the last index. And that means the return value is just going to check whether or not the finish value is equal to 0. And if it is, then we know we can return a value of true. Otherwise, we can return false. And this is the entirety of the algorithm. So it's just a simple traversal in reverse, and we move the finish point as we go along. So with that being said, we can go ahead and write the code on LeetCode. Okay, we're on LeetCode and we can start writing the algorithm. So we can start by initializing the finish variable, and this is going to start at the last element in the nums array. So we can say finish is going to be the length of the nums minus 1. Then we can traverse backwards from the element before the finish all the way until the 0th element. So we can write for I in range, and we can start from the length of the numbers minus 2, and then we want to go until -1, and this is exclusive, so it'll go to 0. And we want to step backwards by -1. This will go in reverse. So then we can check to see if the index plus the value or the maximum jump at that index is greater than or equal to the finish point. So if the index plus the value, so the max jump value, is greater than or equal to finish, then we can just update the finish pointer, and finish is just going to be equal to I. And we just have to return at the end if finish is equal to 0. If it is, then it will return true. If it's not, then it will return false, and that's exactly what we need to solve this problem. So we can submit this code and hopefully it's accepted. And as you can see, the code is accepted and it runs pretty fast. So this is the optimal solution running in big O of n time with a space complexity of big O of 1. So hopefully this video helped you and you learned something, and I'll see you soon.